Hello everyone, welcome to our second video. Today we are going to talk about the 6 trigonometric ratios. So bear in mind that the variable O stands for opposite, the variable H stands for hypotenuse, the variable A stands for adjacent. So the 6 trigonometric ratios is divided into 2 parts, which is the primary and the secondary. So the sine theta, we can call it as SAW, which means sine is equal to opposite over hypotenuse. For the cos sine, we can call it Ka, which means cosine is equal to adjacent over hypotenuse. For the tangent, we can call it TOA, which stands for tangent is equal to opposite over adjacent. Next is our secondary trigonometric ratios, which includes cosecant, secant, and cotangent. For the cosecant, we can call it CHO, which stands for cosecant is equal to hypotenuse over opposite. For the secant, we can call it SHA, which stands for secant is equal to hypotenuse over adjacent. For the cotangent, we can call it COW, which stands for cotangent is equal to adjacent over opposite. Take note that theta is the measurement of the given angle. So for our example number 1, we have here a right triangle with a right angle here, and we have our given angle, which is 45 degrees, and the side that is opposite to our given angle is called the opposite, which is the 15, and the side opposite to the right angle is called the hypotenuse, which is the 12, and the remaining side is the adjacent, which is the 9. So first we need to solve for the sine. So as we all know that sine theta is equal to opposite over hypotenuse. So the next step is to put the given here and here, this and this. So which is sine. So let the theta be the given angle, which is 45 degrees, is equal to then the opposite, which is the 15, and then the hypotenuse, which is the 12. Then so this is not the final answer yet, because there we can reduce it to the lowest terms. So we find a number that is divisible by both of the number, which is 3. So sine 45 degrees is equal to 5 over 4, and this is our sine. So since we have solved the sine, which is 5 over 4, next is to solve for our cosine. So cos theta. So as we all know that cosine theta is equal to adjacent. So let's put here cos theta is equal to adjacent over hypotenuse, wherein our cos sine theta is for cos 45 degrees is equal to the adjacent given here is 9, the hypotenuse given is 12, So we can reduce it to the lowest term by dividing with 3, just like what we did to our sine. So divided by 3. So cos 45 degrees is equal to 3 over 4. So our cos is 3 over 4. So we already solved for the sine and cosine. So for the third trigonometric ratio is the tangent, which we all know that tangent theta is always equal to opposite over adjacent. So again, just like what we did with sine and cosine, the next step is to put the given values here in the triangle. So the theta is 45 degrees is equal to the opposite given is 15 and the adjacent given is 9. So we can reduce it to the lowest term because there is the lowest number to reduce, or the common number to reduce or to divide. So tangent 45 degrees is equal to 5 over 3. So this is our tangent. So tan theta is 5 over 3. So since we already solved for the primary, this will be our primary. So since we already solved for the primary, which is the sine, cosine, and tangent, next is to solve for the secondary, which is the first is the cosecant theta. So as we all knew that cosecant theta is equal to hypotenuse over opposite. The next step, just like what we did to the primary, is to put the given values from this triangle, which is 4. So the theta is 45, the hypotenuse is 12, the opposite is 15, opposite of the angle, 15. So we can reduce it to the lowest term by dividing it with 3 because it is the greatest common factor of the two. So cosecant 45 degrees is equal to 4 over 5. So this is our cosecant, 4 over 5. So since we already solved for our cosecant, so let's move on to our secondary trigonometric ratio, which is the secant theta. So we all know to solve the secant theta is equal to hypotenuse over adjacent. So just like what we did with cosecant and the other primary, let's put the given value, which is 45 degrees for the theta. The hypotenuse is 12. The adjacent is 9. So we can reduce it to the lowest term, which is because both of them are divisible with 3, just like the other. So secant 45 degrees is equal to 4 over 3. And this is our secant, 4 over 3. So next, since we already solved for the cosecant and secant, let's move on to the last secondary trigonometric ratio, which is the cotangent. So we already knew that cotangent is equal to adjacent over opposite. So just like the previous 5, the second step is to put the given values from the triangle to the formula. So adjacent is 9 and opposite is 15. So since there is a number that is divisible by these two, so which is 3, we need to reduce it to the lowest term. So cotangent 45 degrees is equal to 3 over 5. And this is our cotangent. 3 over 5. So this is our example in solving the 6 trigonometric ratios using a right triangle. Thank you and see you in our next video.